Hello everyone, welcome to screencast ID SC10220. In today's screencast, we are going to demonstrate how to configure the AP for accelerated multicast. This feature enables the AP to convert an incoming multicast stream into multiple unicast streams. So let's get started. Before we dig deeper on how this feature works, let's try and understand how does multicast work on wireless in general. As per the 802.11 spec, when a multicast packet arrives at the AP, it cannot be transmitted right away. It is supposed to be buffered to the end of the DTIM period. In this example, let's consider that a DTIM period is 5 when the packet arrived. At that point, the AP will buffer the packet to the end of the DTIM period and then transmit that packet on air. Now, this is very similar to a professor giving a lecture in a classroom. The professor, in this case this video server, only talks once, and that information is heard by all students sitting in the classroom. For some reason, if this one student cannot understand or did not hear what the professor said, there is no reliable means to get that information again, because this is an unreliable mode of delivery. So in a nutshell, the spec mandates that packets should be buffered till the end of the DTIM. This can significantly hamper certain applications. It also mandates that the packets be transmitted at one of the basic rates. The reason for this is, if there are wireless clients at the fringe of the network, they should be capable of receiving these packets. The third point to note is, multicast is a one-to-many protocol. Hence, there are no 802.11 acknowledgements in air. Thus, there are no retransmission of packets going downstream, making multicast an unreliable mode of delivery over wireless. So the question then arises, can we make multicast reliable? The answer to that is accelerated multicast. When the multicast packet arrives at the AP takes that packet and converts it into a unicast packets. In this example, we have 3 clients that have requested that stream. The AP keeps a log of this information, and then once the packet arrives at the AP, it creates 3 individual packets and sends it to these clients. Since these are unicast packets, they are acknowledged. Moreover, they can go at a higher data rate. If these were 11N clients, the packet would have gone at 300 megabit data rates. Thus, with the retransmission capability built into this feature, this makes multicast reliable over the wireless network. The lab topology consists of an AP7131N, which is managed by a RF switch. I also have a video server which would be streaming the multicast video. The entire network is a flat VLAN, which is VLAN 1. We will be creating a wireless LAN which is going to be locally bridged, and hence the AP will directly communicate with the video server. The key requirement for this feature to work is IGMP. When a client joins a multicast group using IGMP, the AP snoops that packet and maintains that information. The AP thus knows which stream needs to be converted to unicast. The configuration for the accelerated multicast feature is split in 2 locations. The first one is a wireless LAN QoS policy. This essentially enables the feature. The second part is the radio QoS policy. This dictates how the feature works. Let's get started on the configuration. My RF switch is pretty much in the factory default state. It does have an IP, and I have changed the password from Motorola to symbol. So let's go ahead and log in. Now to configure our feature, we are going to navigate to configuration. We're going to go to wireless and then click on the WLAN QoS policy. By default, there is a QoS policy, and this is mapped to any wireless LAN that you create. Let's go ahead and create our own QoS policy. Let's call it multimedia. Click on OK. Now to enable the feature, navigate to multimedia optimizations. By default, the feature is disabled, as you can see here. Now, there are 2 options to enable it. The first one is to automatically detect the multicast stream. What this does is, as soon as a multicast stream hits the AP will start converting it to unicast, depending on how many clients are associated. Once the packet has been converted from multicast to unicast, it needs to go into a certain queue on the AP's radio. And this setting over here decides which queue it goes into. You could leave it as default if you wish. The other option to enable this feature is to manually give it an IP address. So you could tell the AP that look out for stream 224.0.0.11. What this does is it makes sure that the AP only looks for this one particular stream and not hundreds of streams that show up. Again, you could put this in any queue you wish to. For our demo here, we're just going to set it to automatically detect multicast streams. Click on OK and exit out of here. Let's quickly look at our radio QoS policy settings. We will not create a new policy. Let's just edit the defaults. Navigate to multimedia optimizations. Our first number here is the maximum number of wireless clients allowed, which is set to 25 by default. This essentially tells the AP that only convert the multicast stream for up to 25 clients. If the 26th client shows up in the network, it will get rejected by default. You can tweak these numbers based on what the requirement is. As you can see here, we have another option to revert. This combination tells the AP that when the 26th client comes in, do not reject it, but stop converting unicast to multicast. So you would not have any more conversion, but all the 26 clients would receive the multicast stream. Maximum multicast streams per client. This tells the AP that do not permit more than 2 multicast streams per client. If the client tries to request the third one, it will not be allowed. Packets per second for multicast flow to initiate the feature. So if the multicast stream that is hitting the AP is less than 25 packets per second, we will not do any conversion. Again, you have the ability to change this number. Timer for wireless clients. If the wireless client that had signed up for a multimedia stream but is not receiving it, we will time that out after 60 seconds. Again, you can change that value if you wish to. Let's just exit out of here without making any changes. Let's commit our changes as well as save it. Now let's create our wireless LANs and map our policies. Click on Add. Let's just call this Multimedia. SSID is the same as Multimedia. Bridging mode is going to be local. We're going to be doing local bridging. Our VLAN ID here is set to 1. And our QoS policy, we will choose the one that we created. Let's click on OK. Let's commit and save our changes. Now we're not going to enable any security for now. Just keep it simple. And exit out of here. Let's go back to our profiles. I have 2 7031s, so I'm going to click on the default profile, click on Edit, and go down to Radios. Click on Radio 1. Go to my wireless LAN mapping and map my multimedia wireless LAN there. Let's click OK. Let's click Exit. Let's do the same thing for Radio 2 as well. Let's click OK. Let's click Exit. Let's click on our RF domain. Let's use the default. Let's give it country code US. VLAN control traffic, set it to 1. Click on OK. Commit our changes and save that. Now, under our devices, we only have 2 APs adopted and the RFS switch. As you can see in the default RF domain, we gave them the country code US. The profile is default. We have mapped our wireless LANs in here, and we should be good to go. This is all we need for the configuration of these APs. Just commit and save. The config file for this screencast can be downloaded from the link as seen above. Thank you very much.